Okay, so now that we have talked about graphing the 6 trig functions, you need to be able to do transformations on those graphs. Okay, and so I am not going to ask you on the test to do a transformation for a cotangent or a secant or a cosecant. So I'm going to limit it to sine, cosine, and tangent. So you've got an example of each one here. All right, so what you need to remember is that this is going to be talking about whether you're looking at maybe a change in the period or a change in the amplitude or maybe a flip vertically over the x-axis. All right, so on this first one, you want to remember that a number inside the parenthesis, like that 4, is going to change the period on the graph, and a number in front of the function is going to have an impact on the amplitude. And if you have multiple things going on inside a function, you always want to start with the period change first, because that's going to determine your tick marks on your graph and let you get that graph set up correctly. All right, so what I'm going to do for the sine graph is I'm going to say to myself that the original sine graph starts at 0 and ends at 2 pi. And so I'm going to take this 4x and I'm going to put it inside that inequality. And my goal now is to get an x by itself in the middle of that inequality. So I'm going to need to divide all 3 parts by 4. All right, so that's going to give me a 0 on the left, an x in the middle, and then reducing that fraction, it'll reduce to pi over 2. So this is now my new starting point and my new ending point for my graph. So my graph will start at 0 and it's going to end at pi over 2. And I know that the graph is based on 5 tick marks, so there's going to be 3 marks in between. Now, to determine the spacing on those tick marks, remember that you're going to take the distance of the graph. So that's from here to here. So the distance is going to be pi over 2. And you are going to divide that distance by 4. And the reason that I'm dividing it by 4 is because there are 4 sections. 1, 2, 3, 4. So we're going to divide it by 4, and that will help me determine what to use for the tick marks. All right, so we're going to do keep, change, flip. So we're going to keep the pi over 2. We're going to change the division to multiplication. And we're going to flip the 4 and make it 1 over 4. And so when we multiply, we're going to get pi over 8. And that's going to be our spacing on the tick marks. So we can just kind of count them out. We can say this one is going to be 1 pi over 8. This one's going to be 2 pi over 8. This one's going to be 3 pi over 8. And then the last one, you already have it marked off, but we tend to write it down here just as kind of a check. Make sure that 4 over 8 reduces to 1/2, which it does. That's an indication that you have not made a mistake in your spacing. So I'll erase that. All right, I also want to reduce any of those fractions that can be reduced. So the 2 pi over 8, that one will reduce to pi over 4. Okay, so that takes care of the period change. Now the amplitude is going to now stretch to 5 and -5. So when you mark off your tick marks on the y-axis, you want to go up to 5. And down to -5. All right, and from there we're just drawing our standard sine graph. So we know that the sine function crosses the x-axis at the first, third, and fifth points. So I'm going to go ahead and zero out those points, first, third, and fifth. We know that the second point is normally at 1, but now with the amplitude change, it's going to be up at 5. And the fourth point is normally at -1, but with my amplitude stretch, it's going to be at -5. All right, so once you have those points plotted, you can come in and connect your graph. All All right, and then the only other thing that you need to be able to do here with this graph is determine period and amplitude for the new graph. All right, so the period is going to go from 0 to 2 pi, so that's a distance, from 0 to pi over 2, so that's a distance of pi over 2. All right, so I'm going to say that my period is pi over 2. And my amplitude, remember amplitude is always the distance from the x-axis, either up or down to your highest or lowest point. It is always positive. So amplitude is going to be 5. All right, so that's the first one. Okay, so let's move on and look at the second one. The second one also has a period change because I have something inside the parenthesis with the x, and it has a flip because I have the negative sitting in front of the function. All right, so we're going to start with that period change. Remember that on a tangent graph that you are going to use as your starting point negative pi over 2 and your ending point pi over 2. So when we set up that inequality for the tangent, we're going to be putting this thing that's in parentheses in the middle of this inequality. And your goal is to get x by itself. So I think the easiest way to get x by itself is to multiply by the reciprocal of that fraction. So that's what I'm going to do. I'm going to multiply all three things by 3 over pi. All right, so when I multiply the first one, I'm going to see my pi's cancel out. And so I have negative 3 on the top and 2 on the bottom. All right, when I multiply 3 over pi times the middle fraction, I'm just left with x. And 3 over pi times pi over 2, again, the pi's are going to cancel out, leaving me just 3 over 2. So I now have my new starting point and my new ending point for the graph. So I'm going to mark off negative 3 pi over 2 and positive 3 pi over 2. And remember that you are graphing in between two asymptotes. So you will have an asymptote here, and you will have an asymptote here. And the easiest thing to do is remember what the tangent graph looks like. Okay, so normally, I'm just going to sketch it right over here. Typically, our tangent graph does this sort of shape. But remember that we have the negative in front of the function, and so it's going to flip that graph over the x-axis. All right, and so our graph is going to look more like this when it's reflected over the x-axis. All right, that graph, when we talk about the period of the graph, the graph goes from negative 3 pi over 2 to positive 3 pi over 2, or negative 3 over 2 to positive 3 over 2. So this distance right here is 3 over 2, and this distance is also 3 over 2. And when I add them together, 3 plus 3 is 6 over 2, so that gives me a period of 3. And there is no amplitude when we're talking about a tangent graph because the graph goes up to infinity and down to negative infinity. Okay, so then let's look at the last one. The last one goes back to a cosine graph. All right, so cosine graphs plot the interval between 0 and 2 pi, just like the sine did. I know that I'm going to have a change in the period because I have this 1/4 sitting in the front, so I'm going to start there. So I'm going to start by setting up my interval. Remember that your goal is to get x by itself in the middle, so you should have multiplied everything through by 4. So that's going to give you 0, x in the middle, 8 pi on the end. All right, so now you have a new starting point and a new ending point on your 5 key points. So the first point is at 0. The last point is at 8 pi. You have 3 tick marks in between. So this is one where you probably can figure out the spacing. If for some reason you can't, remember that you're going to take that 8 pi, which is that distance from the beginning to the end. You're going to cut it into 4 equal pieces. So each piece should have a distance of 2 pi. So we'll go 2 pi, we'll go 4 pi, 6 pi, and finally 8 pi. All right, so on my amplitude has shifted, compressed to a 1/2. So no longer do I go up to 1, but my highest point is going to be 1/2, and my lowest point is going to be -1/2. All right, I also see a negative sitting in front, which tells me the graph is going to flip. All right, so I know that on a typical cosine graph, I have an x-intercept at the 2nd point and the 4th point. I know that normally my graph starts up here at 1, but this time it's going to start at 1/2, and it's also going to flip. So it's actually going to be starting down here at -1/2. And so once I get that first point sort of plotted out, I can draw the rest, going up to 1/2 and then back down to -1/2. Okay, get rid of all of that. Sorry about that. Let's see if we can finish that up a little bit. Okay, so there we go. All right, and so our period on our graph is 8 pi. And our amplitude, the height of the graph, is 1/2. Remember, amplitude is always positive. Okay, so again, if there are questions as you're looking at this, then you need to ask those questions. You need to email me and ask. Tell me what you don't understand and let me try to explain it to you. You need to be prepared on your test to graph a sine, a cosine, or a tangent function where you either have a period change, an amplitude shift, or a reflection. All right, so again, remember on your sines and your cosines, you're starting off between 0 and 2 pi, but on your tangent, you're starting off between -pi/2 and +pi/2.